Hello physics fans, today we're looking at paper 2 2020 question 6 from AQA, and in this question it's 5 marks, and I have to say it's not that difficult a question. The remote control transmits radio waves to a car aerial, check. The transmitted radio waves have a frequency of 320 megahertz, so what's that all about? Well, frequency is 320 million hertz, so that needs another 6 zeros. And we don't really want to write it like that unless we have to. So we could also write that as 3.2 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. And there's probably at least 1 mark for doing that. So we've been given that the speed of the waves is 3 times 10 to the 8, and we have to find the wavelength. So we need to remember that C is F lambda, and we're after lambda, the wavelength. So that means lambda is C over F. And lambda therefore equals 3 times 10 to the 8 divided by 3.2 times 10 to the 8. So lambda equals 0.9375. And this is wavelength, and length is always in meters. 6.2 is an interesting one because it's a tiny weeny little part of the syllabus which often isn't talked about. What we've got here is a process whereby the electromagnetic radiation, the radio waves, create a current in the aerial which follows the same frequency as the radio waves. So you would write something like this. There is a current created or induced, if you want, within the aerial. I'll just spell aerial, A-E-R-I, within the aerial that has the same frequency, E-N-C-Y, as the E/M, electromagnetic radiation or radio waves. One of the things I really like about this question 6 is it goes from the superbly difficult in 6.2 to the sublimely easy in 6.3. So the answer to this really is that sound waves are longitudinal, whereas radio are transverse. Or you could also say sound waves move slowly. Yes. Compared to radio waves move much faster. You could say that radio can go through a vacuum, whereas sound waves can't. You could say that sound waves are not electromagnetic fields, whereas radio waves are. And so any of those really would do. In 6.4, we're given a graph of time against distance in meters. Now, it's worth pointing out that time and distance, if you have those together and you do the y-axis divided by the x-axis, that's going to be distance over time, which of course you know is speed. So that means that the gradient of this graph is the speed. And as you can see, the gradient is kind of low and getting steeper, therefore the car is accelerating, or you could just say speeding up. 6.5 asks us to find the speed of the car after t equals 20 seconds, and what you might think that you should need to do here is to just take the point 20 seconds here, read off the value of its distance there, and then do whatever the distance is divided by the time. Now that is too easy, isn't it, for 4 marks? And even if you don't understand the physics of why that's wrong, the fact that it's 4 marks tells you that it is. So what you actually have to do here is, of course, find the gradient at 20. So you need to put on some kind of triangle that crosses over at the point 20. Now you'll appreciate it's really hard to do this accurately online. Either way, I'm going to have a go. So you need to create a triangle. Let's go across like this. say to there, and then we'll go up from there. And then it's the velocity v, or the speed, is going to be the change in the y-axis over the change in the x-axis. Some of you might know that as run and rise. So the change in the y is going from that value, which is around about 5.4, down to actually what is 1.4. 1.4. So in other words, the change in the y value for me is 5.4 minus 1.4, or 4. And the corresponding change in the x-axis is 15 minus 30. In other words, 15. Now, if we type that jolly lot into a calculator, 4 divided by 15, 0.27 meters per second. Now, actually, I'm pretty pleased with that result because the mark scheme gives us the answer of 0.28 meters per second. So given the fact that I'm enjoying doing this on a computer screen, I think I've done pretty well there. Well done me. Question 6 continues with another monster 6 marker. We're told that a car accelerates from this to that, and that the value of the acceleration is this. Now, within that, you might think to yourself, well, there's several equations that I might be able to fit that into. Now, let's just move on, find out what the goal of the question is. The work done to accelerate the car is just under half a joule, and it says calculate the resultant force. So that's what we're after. Keep that in mind. We're after finding a value for F. Well, you might recall that work done is force times distance. So that's what we're actually trying to find. We know the work done, so in order to get the force, we've got to find a way to get this distance. So now we can go back to the acceleration figures. It's true to say there are several formulas you could use for this equation, but the one they're wanting you to pick on is v squared minus u squared equals 2as. Now this is one you're given on the formula sheet, so you don't have to remember this one, which is nice. Now a is the acceleration, and s, this is what we're after, because s is the distance travelled. Well, actually it's displacement, but for us we can just think of it as distance, which is what we're after. So let's do some algebra on this. This will therefore mean that v squared minus u squared, let's divide by 2 first, is equal to as. What I did there was just divide by 2, because what I want to do is get s on its own. So now we can divide by a, both sides, so now we get v squared minus u squared over 2a equals s, which is what we want. So v here is the final velocity, 0.52. So writing this out, we have to write 0.52 squared minus the initial velocity, which is 0.12. So 0.12 squared all over 2 times the acceleration, 0.04. Now this is a careful calculation, but when you've calculated this, you will get 3.2 meters. Now this is a difficult calculator question, so I would always advise my students use brackets. So I would say type a bracket, then type 0.52 and square it, minus 0.12 squared, another bracket, then press equals. You'll get an answer for the top line. Then do answer divided by open bracket 2 times 0.04, close bracket equals, and you should get, as I say, 3.2. I like to say to my A-level students, make friends with your calculator, and this is a really good example of why. So, we're almost there now. Let's change the pen colour again. We found the distance that's travelled, and remember, we want to find the force from work done is force times distance. So, work done is force times distance. We need to rearrange to get F equals, and we can do that by dividing by D. So, work done over distance equals the force. Now work done, we're told, is 0.48 joules. The distance we just found, 3.2. Therefore the force equals 0.15 newtons Lot of marks there, lot of working out. It's a great question, love it. Physics fans, is there no end to the depth that this question is going to take us? Another 4 marks here. This time we have to write a piece of text to explain why our car has a maximum speed. So the first point here then is that we have a little car or something and it has a maximum speed, and we've got to explain why. Well, there's an engine inside this car which is going to push it forwards this way, and this has a maximum force that it can provide, maximum driving force that it can provide to the right. And as it gets faster, remember, if we have an unbalanced force, the car will accelerate. So it's going to accelerate to the right in my diagram. As it accelerates to the right, obviously its speed's going to go up. And that means that the air resistance acting against it is going to increase as it gets faster. So what we find is that the resultant force, what you might call Fr, which is equal to the driving force, subtract the air resistance, the resultant force is going to decrease. And so the car will accelerate less. Eventually, the driving force and the air resistive forces are going to be equal, no resultant force, and so the car stops accelerating and has reached the maximum speed. Right, so let's put that lot into words. So the car has a maximum engine force. You could call that driving force. As car speeds up, so the air resistance, let's just call that AR, increases. The resultant force is driving force minus air resistance, which decreases as the car speeds up. Therefore, if the resultant force FOR goes down, so does the acceleration. After some time, the air resistance and driving force are equal, and so there is no more acceleration, and we have reached max speed. So, lots to think about in there. Nothing wrong with drawing a diagram if it helps you, but really we're looking for some text here. So I've made 5 points when we needed 4, but hey, that's cool.